Hi everyone, welcome back. Today we're solving count number of trapezoids 1. So the problem states that we are given a 2D integer array points where each point has an x and y coordinate on the Cartesian plane. And it also tells us that a horizontal trapezoid is a convex quadrilateral with at least one pair of horizontal sides. And the horizontal sides, they have to be parallel to the x-axis. And it tells us that two lines are parallel if and only if they have the same slope. And finally, we want to return a number of unique horizontal trapezoids that can be formed by choosing any 4 distinct points from the array points. So if you look at this example, we can return 3 because from these points, we have these 4 points where they have two lines that are parallel to the x-axis. And then we can also form it with these 4 points, and we can also form it with these 4 points. So that's why we return 3. So now that we have seen some examples, let's get to how we can solve this problem. Now, to solve this problem, we will be using this formula, which tells us the number of pairings we can make. So let's say if we only have one color, then we cannot have any pairing. So 1 times 0 divided by 2 will be 0. Now, let's say we have 2 colors, red and blue, for example, then we can make one pair. And as we can see, 2 times 1 divided by 2 is equal to 1. If we have 3 colors, so let's say blue, red, and green, then we can make 3 pairs. 3 times 2 divided by 2 will equal to 3. And if we have 4 colors, then we can make 6 pairs. 4 times 3 divided by 2 will equal to 6. Now, in order for a line to be parallel to the x-axis, we know that the two endpoints need to have the same y-coordinate. Now, using the previous formula, we know that 2 endpoints can make one line and 3 endpoints on the same y-coordinate can make 3 lines. So what we can do is we can group them by their y-coordinates and find out how many lines we can make and multiply them over. And that way we can find out the number of trapezoids that could be made. So for example, right here, we could make 1 line and we could make 3 lines here. And we can make 3 horizontal trapezoids. We can do it this way, we can do it this way, and we can also do it this way. And if we have more y-coordinates up here that have the same y-coordinates, then same thing. We will multiply the y-coordinates up here by the number of edges that we have so far, which is 4. 1, 2, 3, and 4. So how we can solve this problem is we can group all the y-coordinates into a hash map. And then we will go through each y-coordinate and calculate the number of edges that we can make using this formula. And then we can multiply the edges by the total number of available edges, and then we will add the product to result. And after updating result, then we can update the total by adding edges to total. And we'll continue until we get to the end of the y-coordinates. So let's go through this example real quick. So we see that there are 3 y-coordinates at 0, and using this formula, it can make 3 edges. However, we still don't have any other y-coordinates yet, so we still cannot make any horizontal trapezoids, so we still add 0 to result. However, after that, we need to update the total number of available edges. So now that we are at 2, we see that there's 2 y-coordinates and it can make 1 edge using the formula. Now 1 times 3 would be able to form 3 horizontal trapezoids, so we will update the result to 3. Now we need to add edges to the total, so now there are 4 available edges. And up to this point, now we are at the last y-coordinate, which is 3, and there are 2 of them, so it can also make 1 edge. And we will multiply by edge by the total number of lines available, which is 4 of them. 1 times 4 is 4, so add to result, that's 3. Now result is 7, and then we need to update total, which is 5. And now that we have come to the end, we can return 7 as our result. So the time complexity would be O of n, where n is the number of points, because we will have to iterate through all the points to make this y hash map. And the space complexity will also be O of n, because this hash map can take up to n space. So now let's get to the coding part. So first we will set the hash map called y, so default dict of int. And now we need to set this number mod because the answer may be very large, so we will divide by this number as said in the problem statement. And we will set result and total both to 0. And now we will loop through the points. So now we can group the y-coordinates in the y hash map. And now we will look through the values of y, which is the y-coordinates. So for p and y values, and we'll use the formula to calculate the number of edges. So p times p minus 1 divided by 2. And then we will add the product of edges and the current total available to the result. And then we will update the total available edges by adding edges. And then we can return the result modulo by mod. Let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.